Welcome, fellow electricians and DIY enthusiasts, to the ATO channel, your ultimate destination for electrifying knowledge. Today, we're diving into the world of electrical measurements and exploring an essential tool for electricians and technicians, the Multimeter. Join us as we explore the ins and outs of this remarkable device and discover how it can revolutionize the way we measure electrical current. First, let's talk about what a Multimeter actually is. A Multimeter, also known as a current clamp or ammeter, is a handheld electrical testing device that combines the functionality of a multimeter and is characterized by a set of jewels that is used to clamp around a conductor to get a measurement. As opposed to the traditional current measuring approach, where you'd have to disrupt an active circuit and put your meter in series with a connection to measure the current on the circuit, with a Multimeter, we do not have to do that. The jewel opening offers a non-intrusive and efficient way to measure current in electrical circuits. This is one of the main advantages of Multimeters compared to traditional multimeters. With their unique design, Multimeters are ideal for quick and easy measurements. But that's just the beginning. Today's Multimeters compact with a range of advanced features, from digital displays for easy reading to true RMS capabilities for accurate measurements. These devices are equipped to handle various electrical parameters, including voltage, resistance, frequency, and even temperature. And to get to know the device better, let's take a closer look at the components of a typical Multimeter. Like we said before, the most prominent feature of a Multimeter is the straw-like structure, which can be opened and clamped around a conductor to measure the current passing through it. The straw-like structure usually has a current sensor embedded in it. There are two types of sensors used, a current transformer or Hall sensor. The Multimeter with a current transformer typically has a magnetic core inside the plastic housing here. If you open up the jewels, you may see part of it. And this type of design is used to measure alternate currents only. Instead, there is no magnetic core placed under the plastic lid of a Multimeter with a Hall sensor. The advantage of such kind of design is that the Hall sensor can detect both alternate and direct currents. More and more Multimeters are now using Hall effect devices to measure both AC and DC current. And speaking of the open and close action of the jewels, the Multimeter surely comes with a prominent trigger button on the side to conduct this action. The clamp-on often has a real nice spring-loaded feel to it. Additionally, some Multimeter models, like what we have here, usually have a dial and several buttons located on top of the instrument to control different functions, such as selecting the measurement mode, adjusting the range, and activating additional features like frequency measurement, inrush current measurement, continuity testing, and temperature measurement in advanced models. And an easy-to-see digital display comes at the lower part to show the measurement results and provide visualization of any instructional info, and here at the lowest part is where the test leads go. Common jack on the left and the input jack on the right, and they are color-coded to their matched black and red probes. Some advanced Multimeters have some more remarkable capabilities that allow them to be more handy and helpful. For example, a Multimeter with an LED flashlight slightly above the middle of those clamp jewels is going to come in handy for you if you're working in a dark area or need extra light. What's more, the NCV function, namely the non-contact voltage testing, may also be found incorporated in some advanced models just like this one. This is what the jewel head will look like when the meter features the NCV function. The jewel head would have a protruding part at the top, which is where the NCV live tester is located. Besides, you'll see on both jewel tips here that there are little notations that indicate this Multimeter is equipped with this outstanding feature, which, complete with the sounding light alarms, will be triggered if you get it close to a live AC source in its detecting field. So, how does a Multimeter make measurements? Let's go ahead and look into its internal workings. While the inner workings of specific Multimeter models may vary, they generally operate based on the principles of magnetic induction. Like we mentioned in the component section, the key element of a Multimeter is a magnetic field sensor, typically a Hall effect sensor or a current transformer. This sensor detects the magnetic field generated by the current flowing through the conductor. It then produces a corresponding voltage signal. The voltage signal from the magnetic field sensor is sent to the meter signal conditioning circuitry. This circuitry processes and conditions the signal by removing noise, filtering out unwanted frequencies, and amplifying it to an appropriate level for measurement. Next, the conditioned voltage signal undergoes analog to digital conversion using an analog to digital converter, ADC. The ADC assigns numerical values to the voltage signal, which can then be displayed on the meter's digital display. A microcontroller or microprocessor inside the clammeter interprets the digital signal from the ADC. It performs calculations and conversions to display the measured current value on the meter's digital display. The microcontroller may also handle additional features and functions of the clammeter, such as range selection and data logging. Now that you understand the inner workings of a clammeter, you'll have more confidence in using this versatile instrument for electrical measurements in your projects or professional work. With that being said, why should technicians invest in the clammeter? There are several key reasons for that. As we mentioned before, the biggest advantage of a clammeter is its non-contact or non-invasive current measurement function. This feature ensures enhanced safety and efficiency. Gone are the days when electricians have to manually cut into the device wire and insert the meter's test leads into the circuit to measure. Modern clammeters feature a simple operation, intuitive panel functionality, and display their readings on the digital screen. Very straightforward and approachable, even if you're a newcomer into this. One of the good things about clammeters these days is their better accuracy for a wide range of measurement options. Another coolest thing about a clammeter is the versatility of it. In spite of its small profile, it can do multiple things. In addition to measuring current, a clammeter can measure voltage, resistance, capacity, temperature, and many more, thus enhancing usability and making it an all-in-one testing device. Portability is another unmatched benefit of clammeters. Their sleek and portable design makes them easy to carry and use in a variety of settings. For electricians on the go, this would be a great kit to have on the tool belt. Some advanced models have data logging and communication features that allow measurement data to be transferred to a computer or other devices for further analysis. Clammeters have become an indispensable tool in modern electronic testing and troubleshooting. From DIY enthusiasts, electricians, HVAC technicians, and maintenance professionals, clammeters have revolutionized the way we diagnose and troubleshoot electrical systems. Firstly, clammeters are handy for do-it-yourselfers who want to measure the current draw of home appliances, check wiring connections, or perform basic electrical troubleshooting around the house. Secondly, clammeters are essential in industrial environments for monitoring and troubleshooting electrical machinery, motor control systems, and power distribution systems. They can help identify issues such as motor faults, unbalanced loads, and abnormal current draw. Additionally, in the field of HVAC, clammeters are used to measure current in motors, compressors, and other HVAC equipment to ensure they are functioning properly and not drawing excess current. Lastly, in electrical maintenance and troubleshooting, clammeters are invaluable tools for tracking the current draw of appliances, identifying overloads, measuring electrical consumption, and detecting faulty components in electrical systems. And there you have it, the clammeter, a must-have tool for anyone working with electricity. It offers convenience, safety, and accuracy in measuring electrical currents. If you're looking for a perfect clammeter, you can find a wide selection of high-quality clammeters at ato.com. Click the link in the description box to explore our range and make your purchase today. Thanks for watching, and stay tuned for more informative videos. See you next time.